1.
Greetings and welcome, ladies and gentlemen. Today we're talking about one of my favorite ways to solve quadratics, friends. That's right, we're talking about completing the square. Completing the square is how my awesome friend from Ghana, Africa would say it, because he was a math teacher, but now he's a doctor. That's accurate statement. I'm friends with him on Facebook. So, first of all, let's do a little recall here. Actually, let me properly label this here. This is a recall, not as in like I'm calling it back because it was bad and it was going to kill you, but because this is something we want to recollect, something we want to remember for today's lesson. So, you might remember this formula when we looked at this right-hand side of the formula. This was called the square of a binomial, which you might recall that. Binomial? No. Binomial. There we go. And the left-hand side is called a perfect square trinomial. Why is it called that? Because it's a trinomial. And there are two perfect squares in there. Yep. And yeah, it's a pattern. Now, if this is a plus sign here, I just want to indicate that this is a plus sign over here. And if it's a minus sign there, it's a minus sign there. And this one is always plus. So you even used this a little bit the other day. I think when you were factoring, factoring using special patterns is oh so nice. Oh, so nice. So, let me ask you this question. Let's see if we could kind of like solve this riddle sort of thing. Let's consider the following. Consider.
Oh, consider.
Consider the following. Let's see here. That's a loud camera fake sound effect from a computer that has no components that could be thrown into a dark room and develop film. Ugh. Phony computer. So consider the following. If I have x squared plus 10x plus blank, and I tell you it's equal to x plus 5 all squared, what would go in the blank?
2.
I'm going to say no.
5.
5? 2 and 5 combined to be 25, and you're both right.
Yeah.
Your team wins. Congratulations. So 25 goes there. High five. Leave me hanging. Don't you worry. Let's keep going. So 25 is what goes there. How do you guys figure out 25?
Guys, they figured it out. Because the plane's in the ocean.
Emily just never talked.
Wait, what?
Accurate. But we also figured out that this perfect square trinomial would have a C term of 25.
Poor people.
So how'd you figure that out?
Because
You just did.
it's 2 times the A term and the B term.
Oh, okay. All right. So 2 times A times B. So you did like what?
No,
2
that's
times
not
X
what I
times 5?
That's not what I meant.
Okay.
I was doing the 10, okay? Because it's the B squared.
Okay, so you figured if this number here was 10 and A was the X.
No, just pretend I didn't say that.
Okay, all right.
Looking at the other side of it.
Over here?
Yeah.
Okay.
It's the B squared.
5 squared is 25. I agree, right? Because this is B, this is B squared. I like it. Now, I like where you're going because that's my next question. What if I wanted you to fill in the blank here and I didn't give you the right-hand side?
Well, then you
Is there a way you could figure that out?
yeah.
Tell us.
Divide by 2.
So take the B, divide by 2.
Square root of the A, and that is B.
So it's going to be 5.
So you're saying that B must have been, on this problem, the 10 divided by 2,
16.
right? Which is
10
5.
divided by 2 squared.
And then squaring it gave me my new C term, right? So C was equal to 5
So
squared.
the blank underneath would be 16.
So here, my B would have been equal to 8 over 4, which is, no, 8 over 2, which is 4. And then C would have been 4 squared, which is 16. I like it. Aha. I like it a lot. Good stuff. Good stuff. So that technique, the process of filling in this blank is literally called completing the square. divide by 2 and then square it. And in fact, that's exactly what I'll recommend for us here as my technique for finding the new C term is what I call that. All right, the new C term, right?
You sounded like my uncle.
Wow,
Like actually, like it was backwards. It's kind of scary.
that's unusual. I don't know how I.
No, Uncle Peter.
Actually, you know what's weird? I'm not an uncle. No, wait, I lied. I'm an uncle on the other side. There you go. I forgot about that. My wife's family. Actually, I've got like 10 nieces and nephews, but not.
All your siblings are done.
So yeah, my siblings are not having kids just yet. So we'll see.
You know, I have a 13-year-old
My
sister.
sister's 7.
Congratulations.
I'll never have any nieces.
Shout out to Moro's 13-year-old sister. She's gonna know how to find the new C term. It's gonna be good.
Her name's
So-
Apple.
So the new C is equal to b divided by 2 and squaring it. Which, what do I mean by this b? Let me specify. What I mean by this version of b is this b, where I'm thinking of it in terms of the ax squared plus bx plus c version of b, not this version of b where I was referring to kind of like the b from the pattern version of b. Okay, so that's one of the poor decisions mathematicians made back in the day, was they could have just chosen other letters, but they didn't. They used the A and the B in 2 different situations. Oh man, you guys, it's so embarrassing. Maybe they would have done better if they had like a 28-letter alphabet or a 30-letter alphabet. I don't know. But anyways, so this B is from this formula. I'm referring to the coefficient of the linear term. Okay, that's what I mean by that. So let's do some examples of this. Examples. Here we go. Doing problems so we know how to complete the square.
Think of all those people on that plane.
Do you think
All their friends.
their lives were fuller as a result of knowing how to complete the square?
Yes.
All their friends and families and pets and co-workers.
You're kind of bringing us down here, Al Molly.
The first
It's
one's
really
a
sad
9.
now.
The second one is
Here, write these down, and we're gonna attack these all one after the other here. Whoa, whoa, Emily.
It's so sad. These poor people are all dead.
Oh, more people died than just them, though. So, x squared plus 6x blank.
it's 9.
How'd you get that?
Because you take half of 3 and square it.
Half of
6 is half of 6.
So
is
6
3.
divided by 2 all squared is equal to 9. And I would put a little plus 9 right in there, right? Bam. Right? Plus 9. I like it. Okay. Let's look at the next one.
Okay, you take half of negative 14, which is negative
Why don't
7.
you let somebody else do a problem, maybe?
Well, because nobody else took up the initiative.
Yeah,
Because
it's
you
all right.
consider good, right?
Let's see. Negative 7 all squared.
49.
49.
Vowel bars, though.
Yeah, so this would have been plus 49. I like it. Okay, let's see. Let's have someone else do this next one.
I have a question.
Preguntas? Yes?
Why didn't you square 9 up there? Because we got 3.
I did 6 divided by 2 is 3. Oh, sorry. You want me to... I see what you're saying. Just to fit the format a little better.
Yeah, just I'd like to see everything.
It's a good point. So that was 3 squared, which was 9, right? 'Cause
Oh, okay.
6 divided by 2. There we go. Good point, good point. So let's see. For this one, this one's a little bit trickier now. What do I do?
It's 2.5.
5 divided by 2 all squared, which is 2.5, and you could square 2.5 and get 6.25, but blah, gross decimals. Instead, let's just distribute the square. 5 squared over 2 squared, which is 25/4. So it's actually cooler if you leave that as a fraction. And wow, this last one is the best one.
Alright, half of negative 1.
So negative 1/2, right, divided by 2, all squared.
Bless you.
Bless you, what is the inside of this parentheses going to become?
Okay, you can distribute that too.
Let's ignore that for now. Let's just figure out a...
A 4. A negative 4.
Now dividing by 2 is the same as multiplying by the reciprocal. So that's actually going to be negative 1/4 all
Couldn't
squared.
you just get that like from the beginning?
You could have. I'm just fully explaining it. And a negative 1/4 all squared is going to be positive 1 squared over 4 squared. Yeah, I'm writing way more steps than we need, but no problem in being thorough during a lesson, even though you don't have to write all this down, on your homework, per se. So 1/16 is what I would add there. Now a little trick when you're dividing a fraction by 2. Div frac by 2. What you do is you just double the denom. Right, so negative 1/2 divided by 2 just is negative 1/4, where I just doubled the denominator. All right, so that's kind of my quicker technique because we'll be doing a lot of dividing by 2 considering it's part of our formula. So what if I asked you to not only complete the square, but what if I added the following instruction? Then factor. That didn't look like much of an F there. Then factor. So if I wanted to factor x squared plus 6x plus 9.
You find the factors of 9 and add these 6.
Or, think about this, I've completed the square, which literally is referring to the fact that I've created a perfect square trinomial pattern. All right.
So the number that you squared put in the C is the number that you put there.
So you're saying that here, this number must go there. I agree. So this one would factor to be x something all squared. And you're saying that the number that I had right before I squared it would go right here. I agree with that. Does anyone see another location where this 3 could come from?
Half of, or no.
Half of 6?
No.
Yeah.
You divide you unsquare that.
Square root
Right.
the 9, yep. So square rooting the 9 would give you the 3, or halving the 6 would give you the 3. Now square rooting the 9 sort of thing does work, but you just have to be aware that, for instance, square root of 49, I might have assumed positive 47. So this minus sign comes from the b term here, and that matches. So there's like 3 locations you could find it. Having the b, square rooting the c, or the number I had right before I squared it when I was completing the square. So let's see this one. This is going to factor to be something all squared. It's going to be x with a what?
Plus
2.5 or 5 over 2.
5 halves. The number right from here, or it's half of this, or it's the square root of that. Right? So this one is equal to what all squared?
x minus
1/4.
X minus 1/4, the number I had right before I squared it. Right, so once these are perfect square trinomials, once I've made them into these perfect squares, I completed the square, they're actually super easy to factor. I call that fast factoring. So let's talk about why is this beneficial to us. And I'm going to slowly build us up to this process. Going to be good stuff here. So let's say I've got something that is written as the square of a binomial, square of a binom. Right, so I've got x plus 2 all squared equals 9. Now, you might be like, wait a minute, I thought having something factored was only helpful if it was set equal to 0. And yes, if you're using the zero product property, that is true. However, watch this awesome trick. Because this is a perfect square on the left-hand side, watch this old trick. I can just root both sides, plus or minus, don't forget it. That's right. And why is that awesome? Because the square root and the square,
Cancel. Cancel.
they just kill each other in a knife fight.
It's just like x plus 2 equals 9.
Square root of 9 is 3. Yep, you were squaring there. And now how would I solve for x?
You just minus 2.
Subtract 2 from both sides. So I've got two situations here. One of them's plus, one of them's negative. So I've got x equals, I'm going to write out this step. You don't normally have to write this on homework. Either x is equal to negative 2 plus 3, or x is equal to negative 2 minus 3. And then I just simplify it. Negative 2 plus 3 is positive 1, or negative 2 minus 3 is negative 5. Right. So if I have something in this perfect square trinomial form, and it's then been factored, what's nice is I can just root both sides, plus or minus, don't forget it, and then I just solve normal. So let's do a problem with one additional step added, where it's not necessarily all given to us, and maybe this would look like some problem that would have been factorable when in fact, actually I don't remember, is this one factorable? Yeah, this one's factorable, but we'll pretend we didn't know it was factorable.
That reminds me of that book where everyone's on that bridge and then the bridge fell with 5 people. Yeah. And then you're right. What was that called?
So-
The bridge.
So let me show you some good steps on how to solve a quadratic when by completing the square. All right, and I've got a handful of steps here for you. So friendly friends,
Oh, sorry.
here's my general strat, okay? This is how you do a little Zergling rush here on this problem. So first, move the old c to the other side. So I'm going to add 40 to both sides. I'll give you a chance to write those steps down later if you're interested. We'll just do the problem together for now. So x squared minus 6x blank equals 40 blank. And now, why did I leave this foreshadowing ominous blank here?
I don't know, you could have just put a 0.
Because step 2 is, I'm going to complete the square.
It's going to be negative 3 all squared, which is on 9.
Right, so I'm going to complete the square.
Plus 9.
So I'm going to add 9 here. And if I can't just add 9 willy-nilly to a problem, it's going to change things. I'm going to add 9 to both sides of that equal sign, friend. Let's keep this equal. Come on, equality, friend. So, now that I've done that, I've completed the square, right? So now I want to fast factor this left-hand side. X squared minus 6x plus 9. That factors fastly. How so?
Okay.
I'm fine. I'm great.
Excuse me.
What do we got? How would you factor this?
San Jose?
X with a what all squared?
No.
A minus 3. Easiest place to find that was right here. Right? Or it could just be half of the b or the square root of the c as long as you take the sign from the b. Right? Lots of opportunities. And 40 plus 9 is 49. Next step they say is root both sides plus or minus. Don't forget it. So let's do this. Root both sides plus or minus. Never gonna forget the plus or minus.
Wait a second, I'm a little confused.
Okay, what's the problem?
Well, what did we do? You see where you circled the 3?
Yep.
What's under that? Like, what is this?
I fast factored, just like when we went from, from this to this, or this to this, or this to this. I was taking the -7 or the 3. I was just fast factoring. So I'm using the pattern now that I have a perfect square trinomial to factor it super quickly in a convenient way. So that's what I did. I took this x squared plus or minus 6x plus 9 and I rewrote it as x minus 3 all squared.
Oh, alrighty.
Right? Good stuff, good stuff. So root both sides, plus or minus, don't forget it. And now I can just solve. Add 3 to both sides. And I'll get x equals, here I guess I'll show you a little bit more there if you need it. X equals 3 plus 7 is 10. And x equals 3 minus 7 would be negative 4. And both of my answers come out oh so nice. I love it. I love it. Now, the benefit of solving by completing the square is it works todo de los tiempos, amigos. Where factoring kind of only works for problems that are factorable. Yeah. Well, actually, I'll pull back to those at the end of the video. I've got one more example I'll do, and I'll have the steps show up in that as well.
Is this a factorable problem?
This one is not factorable. The one I just did a moment ago is factorable, and actually, a clue I'll tell you, the fact that my answers were rational numbers, they could be written as fractions without infinitely long non-repeating decimals, suggests that the problem is actually originally factorable. So here's a problem where you could not factor this if you tried, or at least not with nice numbers. So let's use these little steps over here. Ooh, it's even got the little exclamation mark over there. So first thing I'm going to do, move the old c to the other side. Get out of here, negative 2. No one likes you anyway, right? So I'm going to have x squared minus 7x blank equals 2 blank. Okay, all right, that's fair. I do know that 2 is less lonely than 1 because 1 is the loneliest number that I ever knew. So let's see, how do I complete the square here?
Negative 7 over 2 all squared.
I like it. This man knows his formula. And that does not divide. Ugh. But I can square that. 7 squared is 49.
49 over 4.
All right, so 49 fourths. Plus some 49 fourths. And also, since I usually put this line here, sometimes I'll actually literally use that as my fraction bar. Just because I'm like, hey, what the heck? You know what I'm saying? You can do that.
Sorry.
So, okay, I've just completed the square. I want to fast factor this thing on the left.
Do both sides.
Well, not yet. I got to fast factor first. How does this factor?
The x minus 7
Where'd you get that from?
Half of what?
Before I
Negative
squared
7
it.
halves.
Half of the negative 7, or the thing right there before I squared it, or the square root of 49 fourths with the minus sign from the b term, right? All sorts of stuff coming at me. Now, you know what's funny? You guys are going to be experts at completing the square. The area you're going to struggle in tonight is in whenever adding fractions comes up. And that's just the way things are. Usually we're weaker at the things we haven't done in a while. So to add these fractions, I'm going to need a common denominator. So between 1 and 4, that's 4. So I'm going to have to multiply this by 4 fourths. So I'll have 8 fourths plus 49 fourths. And that looks like 57 fourths, is that right?
Yeah.
And notice actually, because I already know what my next move is going to be, I'm even leaving this little space right here for my next step because I'm planning ahead.
Plus or minus.
And yeah, throwing the root both sides. Plus or minus never forgets. And I get x minus 7 halves equals plus or minus, watch this, square root of 57 up top. I don't believe that's factorable or can be broken down into some factors that are perfect squares. What's the square root of 4? 2. And oh, how nice. Oh, how nice. I can now add 7 halves to both sides. And I get my answers. And because it's got like this crazy thing, I'm just going to write this as x equals 7 halves plus or minus to the square root of 57 halves. So this is one way you could write your answer. Another way, sometimes people combine that over the common denominator, 7 plus the square root of 57 all over 2. That's the same thing. Or you could actually plug this into a calculator, do the plus, do the minus, and figure it out and get some decimal approximations as well. But we're usually not as interested in those. But yeah, so that's the general idea for solving by completing the square. It can handle any quadratic you throw at it. It's just that cool. So thanks for watching, Internet friends. Tienen un día al más bien del mundo.